Hi, my name is Dalton from CTR Electronics, and I will be explaining the Talon FXS. The Talon FXS is CTR Electronics' latest innovation in brushless motor controller technology. The Talon FXS supports various motors from various vendors, with primary support being focused on the Minion. The Talon FXS has a couple of different features. The first one you'll notice is that on all of the input interfaces and the output interfaces, it is a ring terminal. So these are the same ring terminals you would see in the Kraken X60 and X44 and support 632 and 440 style screws, 632 on the power and stator inputs, and 440 screws on the CAN inputs. The other main feature of the FXS, which sets it apart, is the Gadgeteer connector. The Gadgeteer connector is a similar style to the one on the Talon SRX. It is pin compatible with small exceptions. Please see the user's guide, and supports digital encoders and PWM encoders and limit switches. On the front is the JSC interface for connecting to the motor. Alternatively, the Talon FXS does support brushed motors as well as brushless motors from non-FRC specific vendors. With its built-in configuration utility. The Talon FXS supports a wide operating voltage range with nominals between 12 and 24 volts. Being one of our most robust products made yet, it has protections against various kinds of shorts, including stator shorts and Hall effect shorts, and is tolerant to 12 volts on any pin. When working with sensitive electronics, it is important to review the manufacturer's user's guide for installation instructions, and when wiring the Talon FXS, please ensure that the power supply is turned off before connecting. Before we begin installing the Talon FXS, we'll need to make sure that we have all of the necessary components. That is the Talon FXS itself, the two CAN cables, the power input cables, the terminal cover, the Gadgeteer cover, all of the necessary screws. These are all included in the Talon FXS kit, the mounting plate, a 0.6 Newton meter and a 0.9 Newton meter torque wrench. And if you are installing the Gadgeteer cable or the Gadgeteer cover, you will need a T7 bit for the tiny screws that are used to install that cover. Then the extra component is, well, the motor itself. In this case, we're using the CTR Electronics Minion, but you can use motors from third-party vendors as well as non-FRC vendors for hobbyist use. So to get started, let's go ahead and take our CAN cables and note the ring terminals. So these ring terminals are designed for fit with a 440 screw and are torqued down to 0.6 Newton meters. So we'll go ahead and start by grabbing one of the 440 screws and insert it through the ring terminal. Then what I do to make life a little bit easier, since using the torque wrench to initially install the screw can be a little difficult, I take the bit out and use it to get a grip into the screw itself. Then I get it started just by hand and get it hand tight. I repeat that for the other ring terminal. So go ahead and put the screw through the ring terminal, grab the bit, insert it into the screw, and then just get it finger tight. Then we go ahead and reinsert it into the torque wrench. And it will click, telling you that it has reached 0.6 Newton meters of torque. That is not going anywhere. So we do effectively the same process for the power input wires. These are 10 gauge wires with a ring terminal designed for a 632 screw. And this, because it is a larger ring terminal, we will torque down to 0.9 Newton meters of torque. It is important to not exceed the recommended torques on these interfaces to prevent damage to these standoffs. So we will grab one of our 632 screws, put it through the terminal, just like we did for the other ones, grab our bit, and just get it finger tight. Now, the FXS is designed for the wires to come out straight alongside the Talon FXS. So let's go ahead and repeat that process for the negative power wire. And now that we have both of those finger tight, we grab our 0.6 Newton meter torque wrench, torque until it clicks. Perfect. So that is the input wires. The next step is installing the gadgeteer cover. If you are using a gadgeteer cable, which is the recommended way to interface to the gadgeteer port to prevent damage to the pins, you would go ahead and install this cable now. The ones sold on our store come with a right angle, so they just sit nice and flush and go straight out. But in this case, we're not installing that, so we go ahead and take the cover. We go ahead and just push it down. Then we grab the two tiny screws here and here, and just go ahead and put those in. And use a T7 bit. I have this on a electronic screwdriver. And go ahead and install that. There is no torque rating for these screws, just snug. Don't really exceed snug, and you will be fine. Now, the next step is to install the motor. So here we're using a CTR Electronics Minion, which includes 4 cables. These 4 cables are your JST cable, which is used for reading the Hall effect encoders inside of the Minion, as well as the 3-phase cables, which is used for actually driving the Minion. If you are using a non-standard motor, you'll need to consult your manufacturer's installation guide for the phase table, as well as the Hall effect wiring, as well as reading the Talon FXS user's guide on the correct pinout for the JST port. So we're going to go ahead and start by taking our red phase cable and matching it to the standoff that has the red letter A. So this is our red A phase cable, and we're going to take a 632 screw, just like the power inputs, put it through the standoff or through the terminal, and go ahead and get it finger tight. Again, you're going to make sure the wires are going alongside the Talon FXS. If you do it this way, you'll find that the B cable, you'll have to have a kind of a 45 coming out here, and then in most cases you don't desire that. So all 3 phase cables are finger tight. So now we're going to torque them down to 0.9 Newton meters. So they're all torqued down. Now we just need to install the JST cable. So we'll take the JST cable. The lip will face down, and it will just simply slot in and push. And that is the motor installed. Now, the last couple of steps are just adding some protections and the mounting interfaces. So we're going to go ahead and take the Talon FXS cover and place it over. The holes will line up here and here, and you're going to want to double check to make sure you're not interfering with any of the wires. And here it is nice and perfect. We're going to take the same 440 screws that we used on the CAN interface, and we're just going to fit it into this countersunk hole here and here. And you'll use a 440 torque wrench, 0.6 Newton meters, and just go ahead and tighten that down. Okay, and that is your Talon FXS wired to a Minion and pretty much ready to go. Now your mounting options are 1032 threaded holes that are 1 inch spaced on the back. That's right here and here. You can use a 1032 screw or bolt and go ahead and use that and install the FXS that way. Alternatively, we do include a mounting plate, which is 2 inch spaced holes with 2 countersunk holes here and here. And you'll just go ahead and line that up and take the provided screws and just go ahead and get those fingers started. And then you can use that same 440 torque wrench that you had before and go ahead and screw those all the way down. So you have two 1-inch space through holes that you can use to install, and this is 1-inch / 2-inch spacing, 1-inch here and here, 2-inch here and here, and you can use those for mounting with, for example, West Coast box tube, which has 1-inch or 1/2-inch space through holes. And that is installing and wiring your Talon FXS. So let's say you have a Talon FXS and you don't have a CAN encoder, or you have some other third-party encoder, or you have a bunch of mag encoders lying on hand. So with the Gadgeteer port, the Gadgeteer port exposes pulse width interfaces, quadrature interfaces, interfaces for analog, as well as limit switches. You can actually take a Gadgeteer data cable. We sell these at CTR-electronics.com, and you can just simply plug this in. And if the device matches the same pinout as the FXS, consult your user's guide for your device. In this example, I'm going to be using the CTR Electronics mag encoder. You can actually just plug the mag encoder directly in, and the Gadgeteer exposes 5-volt and ground over, and you can just power your mag encoder that way. This will also give you access to pulse width as well as quadrature on the mag encoder. If you have a third-party encoder, what we recommend you do is you grab a Gadgeteer breakout board. You can also find these at store.ctr-electronics.com. Plug this end into the breakout cable, and then solder or otherwise attach your the necessary inputs to that breakout board. And that's how to use the Gadgeteer port on the Talon FXS. So now that you've assembled and wired your Talon FXS, we can go ahead and talk about the configuration and controlling aspects of it. So before we get into that, I want to go over just the setup I've done here. So I went ahead and mounted the Minion and Talon FXS to this 3D printed mounting plate, and I have attached the CAN connector to a canivore. A canivore is a USB to CAN FD adapter that is supported on Robrio, Linux x86/64/ARM64, as well as Windows, and allows you to very easily configure without using another CAN device. For a full list of support platforms, go ahead and check the API documentation. Now, we're going to go ahead and swap over to Tuner to see what that bring up looks like. So I have Phoenix Tuner here. This is the general interface. You can install Phoenix Tuner from the Microsoft Store, the Apple App Store, and on Android and iPhones as well. So what we want to do is we want to enable CAN over USB. This starts what's called a diagnostic server, which allows us to communicate with the device. So we have installed Phoenix Tuner. We've started the Canivore diagnostic server, and now we don't see any devices. Well, that's because we need to first firmware update our Canivore. So we're going to go ahead and go to the Canivore, and we're going to select just the newest version. And we're going to go press Update Firmware. So now that it's been updated, we want to change the name. So in the API, the name of the Canivore is actually how you interface with it. So all of our device constructors provide a overload where you specify the CAN bus interface. So if you're using a generic socket CAN adapter, you will just use the interface name. If you're using a Canivore, you will use a Canivore name, and you will need the drivers installed. Driver installation instructions can be found on the Phoenix 6 software documentation. So I'm just going to go ahead and name this Cool. So I've named the Canivore Cool. So in code, I would construct it with the name being Cool. So now we can actually see that we have our FXS here. So we're going to go ahead and click on it. And this will give us a bunch of stuff, and you'll see an error message at the bottom, and that's just because we're not on the correct firmware, as noted, an unknown or beta firmware version. So what we'll want to do is there's a couple of fields of importance here: ID, name, and then a similar firmware update as before. So before anything else, let's go ahead and firmware update. Okay, so now that we firmware updated the device, you can see that that error message has gone away. And the next couple of things we're going to do is we're going to want to set an ID. So the two things to interface with a device in the API when you're actually writing a robot program is the ID as well as the CAN bus interface. So on a CAN board, that's going to be the CAN board's name. If you're using a socket CAN adapter, that's going to be the interface name. So we're going to go ahead and say our ID is number 5. Now, one thing I want to talk about real quick is that you might want to rename your devices away from ID 0. So out of the factory, all devices are named ID 0. And what that behavior results in is on CAN, an ID of 0 means that all the devices are kind of talking over each other. So you might not reliably get communication to a device when you have multiple devices with the same ID. So you need to make sure every single device, FXS, Minion, otherwise, has a unique ID. So here I named 5. If I get another FXS, that's going to be ID 0. So they'll talk and they'll be able to communicate together. So next thing is name. This is just how you want to visually identify it. It's not actually used for anything in API. So we're going to call this cool Talon FXS. So we can just go ahead and name it. Doesn't do anything, just useful for quickly identifying the device when you're in tuner. One thing I want to go over a little bit is the status LEDs. So to show off the status LEDs, you can see them on the device. All of our products have status LEDs, and the blink codes are actually very important. If you look at our user's documentation, you can actually see what the table of blink instructions are. But the important thing to understand is that typically blinking orange on our devices means that, hey, CAN is connected. There are some exceptions to this, but generally devices, when they're not doing anything and they are in a healthy state, are going to be blinking orange, whether alternating orange or simultaneous orange. So I went ahead and loaded up on Phoenix Tuner a self-test. A self-test is kind of a snapshot of the device in any given moment, away from any of your robot code that may be causing problematic issues. So it's a very, very useful diagnostics tool. So here we have an animation of LED. So let's say your FXS is buried deep in a robot or EV system and you cannot see what's going on. But you can see that it's connected, but it's not driving for some reason. Well, that's where you can look at here. And this LED state, orange off, orange off, orange off, just means it's not doing anything, but communication's good. So why is it not doing anything? Now that's something that is a little bit of intuition as well as understanding and reading through the documentation. Now it's not doing anything here because it's disabled. We're not telling it to do anything. So let's go ahead and just to get a fresh start here, let's go ahead and factory default this. And we're going to go ahead and try driving this motor. So we're going to go ahead and head down to duty cycle. Duty cycle is -1 to 1 proportional to battery voltage. So if you're on a 12 volt system, 1.0 is going to be 100% duty cycle or 12 volts. If you're on a 24 volt system, 1.0 is going to be 24 volts. There's multiple control modes, so you want to read the API documentation and understand which one best fits your use case. Here we just want to command plain duty cycle. So we're going to go ahead and enable here. And I'm driving it. It's not doing anything. And if I look at the FXS, it's actually blinking orange-green. Let's take a look at that self-test here. So in the self-test, it says connected motor unknown. That's strange. And orange-green. And then the user's documentation, it tells you that no motor's been selected. Because the FXS cannot dynamically know what motor is connected to it, you have to go and select the motor. And you can do this in your code, or you can do this in Tuner. If you do this in Tuner, just make sure you don't accidentally overwrite this in your code, for example, by applying a factory default. So we're going to go ahead and disable, just to be safe. And we're going to go scroll all the way down until we see commutation. We see that there is a config called Minion. So we're going to go ahead and select that. You can see a variety of other options here In a newer firmware version, there is also the ability to select a generic brushless motor, But here we're just using Minion, so we're going to go ahead and apply that. So if we see here, it did succeed. So great. So we're going to go ahead and try enabling again. I'm going to do not 100% duty cycle. Just let's try roughly around 10%. We're going to go ahead and enable here. And hey, the Minion is rotating, the Minion is spinning, and that's all you would need to start driving. A lot of questions we get with the Talon FXS is, I don't have a Minion, I got this motor off of Amazon or Alibaba or some third-party site. And while we would love you to use our recommended motor, as that's first class support, yes, you can use those third-party brushless motors or brush motors. The important requirement here is that currently the Talon FXS does require that the brushless motor does have Hall effect encoders built into them. So if your motor is a 3-phase DC brushless motor with Hall effects, you can wire that up into the Talon FXS. Please consult the user's guide as well as the documentation for this, and note that there is a little bit of a bring up in terms of figuring out your exact motor's configuration. You might have to reach out to the motor manufacturer for finding the necessary information. Can I use the Talon FXS with a PWM or quadrature encoder? Absolutely. The Gadgeteer port actually exposes discrete pulse width or quadrature inputs that you can use for third-party encoders. And you can actually use both a pulse width encoder and quadrature encoder at the same time. However, you can only use one of those for closed loop input. So, for example, you might have a pulse width encoder for seeding your position, and then you want to do your velocity or position control off the quadrature encoder, which tends to be a little bit higher resolution. You can do that by using our API and then switching over to using the quadrature as the closed loop controller. Can I use the Talon FXS with limit switches? Absolutely. There are 2 pins on the Talon FXS, one for forward limit, one for reverse limit, and these configs are enabled by default to disable output whenever they are closed. And that is everything you need to know on how to use the Talon FXS. Make sure to visit CTR-electronics.com for your next project. And thanks.